Welcome, everyone. My name is Tom. I'll be your host today. We are glad you are here to spend a few moments with us. Before I hand it over, a few housekeeping notes. Obviously, this webinar is recorded. We will send everyone a link to the recording afterwards. So if you have to drop early, you won't miss anything. If you have any questions, use the Q&A box, the feature in the Zoom below the screen. And we will try to address all the questions at the end of the session. We have a dedicated time for it, so just keep plugging and keep adding your inquiries. Now, a word on why we are all here. So here is the uncomfortable part. Most enterprises already have AI agents running, and most security teams can't say how many. That's what today is about. Not whether to allow agents, but how to see them and keep them inside the lines. Nathanael's going to show you a practical way to do exactly that. And about the speaker, Nathanael. Nathanael Iversen is the chief evangelist at Zentera. He helps organizations grasp agentic AI control and zero trust strategy, drawing on deep expertise in networking and security, and more than 2 decades of experience across systems engineering, product management, and technical marketing. Nathanael actually began his career designing large-scale data centers for U.S. Air Force, and he holds a degree in communication system design from Community College of the Air Force. I think I got this right, Nathanael, right? I hope so.
All good.
Well, Nathanael, welcome, and over to you.
All right. Well, fantastic. I will go ahead and share out the presentation that we're going to use, and we will go ahead and get started. Well, it is my pleasure to spend the next couple of minutes with you talking a little bit about how to secure and control some of your most important assets in a world in which agentic AI is growing rapidly. So just to give a brief agenda of the things that we'll cover together today, I'm going to introduce you to Zentera in the chance that you haven't actually run across us in the marketplace or in a conference room yet. We'll talk a little bit about the problem and how it's manifesting and some of the conversations that we've had with some of our customers. And we'll go through 3 architectural requirements that have come out of those conversations. So that's going to be things that I think are durable. We'd obviously love for you to get an answer to those things using Zentera, but I think by way of just mentioning the problem, you're going to find that these architectural requirements are durable. They're going to be things that you'll be able to apply to all kinds of other vendor conversations that you might have in the coming months. We'll talk a little bit about practical application, and we'll wrap it all up with some Q&A. So as Tom said, feel free to drop things in the chat. We know these are active conversations inside your organization. They're active conversations inside ours. And we're at the point in this technology rollout and adoption curve where the more that we share and the more that we talk amongst ourselves, the better the result is for everyone. So with that, let me introduce you briefly to Zentera. As our mission statement, we want to help people secure and control access to our customers' most important assets. And that's a broad mission statement. We'll kind of narrow that into exactly some of the ways that we do that over the coming conversation. But suffice it to say that if you have a Tesla car or have ridden in one, if you own a Toyota or have ridden in one, if you have an Apple device from a phone to a tablet to a computer, you are actually using computer chips that were designed in an environment protected by Zentera. About 250 of the world's largest semiconductor manufacturers all do some of their design work inside of systems and environments that Zentera is protecting. So even if you have not heard of us, I guarantee you that our impact or our usefulness is something that you've experienced, albeit quietly in the back end. So our vision is simple. We just want to see a world where the data and systems that people use are secure from untrusted access. We observe that humans and agents are going to need access to the things that they need access to, but we believe that transparent and invisible controls that enforce organizational intent are present. And we think that's probably one of the biggest gaps that happens right now in AI is really having independent, invisible controls that can enforce organizational intent. So more on that in a moment. I'm going to give you a brief background. Our product line, if you will, kind of has four major components. It's got a thing that we do around segmentation of compute and computing assets. There's a portion of our business that is around doing the same in OT environments for manufacturing and other places where software security doesn't work. We have a big portion of our business that's AI related, and that's going to be our focus today. And we have a portion of our business that is around connecting things together using overlay technology. And so that's another part of our business we won't spend much time talking about today, but this just gives you a sense of kind of our background. We're coming to you with a history in helping people to keep important things separate from other things. And the very basic idea that we've had for years is the idea of a virtual chamber. It's a virtual space in which you put important things. What kind of important things? Everything from Kubernetes containers, virtual machines, bare metal servers, OT devices, all of these things. When they go inside the chamber, we can put a zero trust perimeter around them. We can close all of the unused ports. We can put a zero trust policy in for the core services. And in so doing, we will eliminate about 90% of the ways to east-west compromise anything inside the chamber. So a very simple strategy with a very big impact. It almost shuts down the ability for things to move laterally across the infrastructure undetected. And so that's our history. We have the same capability of doing this for OT environments. And so if you're on this webinar and you're a manufacturer, we have things that will do this even for your SCADA systems, for your elevator controls, for your HVAC controls, for your medical equipment, for your critical infrastructure that's helping with oil and gas or electrical or other types of utility distribution. These are look like switches, but are actually inline devices that are meant to be able to act as an agent for things that do not have the ability to take an agent. So these are layer 2 transparent. They look like switches, but are not. And I'm not going to belabor their functionality, except to say that the history of our company is that of putting our capability onto servers and compute devices, and then putting our enforcement point in front of OT infrastructure, making chambers, and then connecting these chambers so that people can talk, information can flow, all of that. There's a portion of our business that is related to universal ZTNA. And so we can allow even third parties and others to come in across the internet and terminate only on the devices that they're supposed to do. So that's the history. And with that as a backdrop, I think it will help you to understand where we're coming from and the kind of solutions that we'll be able to offer in a very holistic way for artificial intelligence. But let's pivot away from all of that for a moment and spend the rest of our time talking about agentic AI and the things that actually are facing all of us. And we're going to make the unsurprising acknowledgement and assertion that there is a new sprawl, and that sprawl is very quickly becoming AI agents. This is a very old technology story. First, there was sprawl with servers, and we ran out of space in data centers, so we switched to virtualization, and we still ran out of space in the data center, so we went to the cloud, and there we're limited by the amount we can afford. The interesting thing is that agents are just another way to handle compute and to handle automation. The interesting thing is that agents can write other agents. And so for that reason, we anticipate that the ability of agents to sprawl, if you will, is perhaps going to be faster than some of the adoption curves that we've all seen in the past. Now, this would be a great chance. I think we've got a poll question. We're actually curious, how many AI agents do you already have running in your environment? If you know, you can go ahead and check that off. We'll leave this open for a moment, and then we'll share with you some of the results that we have. We just got done doing a rather extensive global survey of a bunch of different enterprises, all of them ranging from mid-tier enterprise up to the very large. And so ranging from a variety of manufacturing, retail, all the different industries, banking, so on and so forth. And so we'll share with you the results, and we can compare kind of the attendees on the webinar, if you will, to how things are in a broader format. And it'll give all of us a chance to see just exactly where we stand. So while that is wrapping up, go ahead and get your answers in, and we'll take the poll down in just a moment.
Yeah, I'm trying to encourage now, our attendees. I only see 60-70% participating in this. Please don't be shy. This is
You can do it. Click a radio button.
all right. We're getting there.
All right, fantastic. Well, if we can wrap this up, Tom, and we'll move on.
All right. Let me share the result.
Okay, well, while those results compute, okay, so we have a few people with none, but you'll notice that almost everybody, 90% of the people who responded, have some agents, and roughly at least looks like at least a third are 11 to over 50. Now, that's interesting. That's what's happening inside this room that we're all in for a brief period of time. Let's look at what is happening out there in the world. Here's an interesting statistic that came out of us doing, as I said, a fairly large survey. 64% of organizations currently operate more than 50 agents, a figure expected to reach 76% within 12 months. Wild. It's data. You could be higher than that. You could be lower than that. But it's just interesting that even the survey results that we saw, agents are out there. The interesting thing is, where are the agents coming from? One of the things that we learned is that the primary source of AI agents is actually software vendors that you already get software from. In other words, if you're a Salesforce customer, you've probably got some Salesforce agents. If you're a Workday customer, you probably have some Workday agents. And of course, depending what industry you're in, if you're in semiconductor, then you would have different software vendors and agents from those vendors and so on and so forth. And of course, some organizations are building their own. But what's interesting is, what's the expectation? The expectation that we heard is that 50% of organizations expect to operate more than 100 AI agents within the next 12 months. So whether they're part of the, roughly 40% that don't have 50 agents, half the people expect that they're going to have more than 100 over the next 12 months. And so this makes it seem like there's a certain inevitability to the growth of agents in the environment. And in fact, if you've got people using Claude to write too long emails, or Copilot to write too long emails, there's probably also somebody who is actually using Claude Code or something else to, try to make part of their work faster. So this journey for us started in last November, when some of our customers, some of the largest semiconductor manufacturers in Taiwan, they came to us with a series of questions and observations. They had boards that were basically telling their IT organizations and their design populations, use AI, use as much of it as you can, find all the accelerated workflows you can. If you can accelerate design, if you can accelerate tape out, then you go ahead and do those things, please. And of course, nobody stopped to consult with security or infrastructure. There was business to be done and acceleration to be had and profits to accelerate. And so these are some of the questions that their security team came to us with, which are simple things around visibility. How many do I have? Who's running them? How do I make a policy when everybody, each department and each work group is doing their own thing? I don't have any controls. What kind of controls do I need to be able to enforce things? And if an agent made a change, can I know it, let alone prove it? In other words, if a tree fell in the forest, would it make a sound? And they wanted to know that if an agent fell over in the forest, it would make a sound. And so this started a conversation that, in working with them, started to help us understand the problem. And one of the things that we learned very early on is that these AI agents were becoming part of human workflows, but there was no project-aware enforcement boundary for the AI agents. In other words, if I launch an agent, it's launching with Nathanael's user permissions. Well, my user permissions involve like being able to see my paycheck and signing up for benefits. That's probably not something that I want an agent to be able to do. And yet, what boundary would prevent an agent with my permission from going and doing those very things? So we kind of dimensioned it around the ideas that you can see on the screen, that the perimeter is opening, even some places that had very closed data sets, things that are very sensitive to organizations. All of a sudden, people are starting to try to run code against it or ask an LLM to look at it or upload, heaven forbid, information to an LLM. The agents are multiplying. We noticed that. And in some cases, the IP is shared. It might be yours. It could be also part of a business partner, a sales partner, a distribution partner. And so are they using agents? Are they trying to use agents on the data across a VPN? Who knows? And what we found is that it's not yet clear exactly who owns the boundary. We're at the stage in the cycle where it's mostly about, can we accelerate the work? Can we find economic benefit? And so we realized that what was necessary was this first thing of a project aware boundary. And that is what led us to the first architectural observation. And the first of the three architectural observations is that you're going to need to monitor and control agentic behavior at three locations in order to be successful. We actually did some trials with our customers to come to this conclusion. As you know, from my opening, our company already has some ability to control endpoints and backend infrastructure by placing them in these chambers, by setting up user access and things of the sort. So we have some capability to have an agent that goes on to endpoints in a very lightweight way. We have the ability to put some controls and some chambers around OT servers. And so the very first question that we were asked is, can you modify your agent just so that we can find out and enumerate what's happening on the user endpoints? And so we dutifully did that. And one of our customers, they had 1,500 agents running across 300 projects and no one knew. And so you can imagine that that led immediately to another conversation, which was, is there a way to sandbox those agents? Can we make sure that there's some control on the endpoint, on the engineered desktop, on the finance laptop that can actually put those agents inside of a sandbox? And so you can understand why I say that you're going to have some endpoint controls in order to control the agent. But what we found is that if you just put some controls on the endpoint, the agent's going to do everything it can to circumvent it. If you say you don't have permissions to do this, it'll write itself a Python script, and the Python script will go out there and do it with the permissions of the system. And so we realized that having endpoint controls wasn't enough, and that there was going to need to be some AI aware controls that are actually aware of the agents. There was going to need to be a way to guarantee that agent traffic actually could not bypass these infrastructure controls. And in that way, all of a sudden it becomes possible to control agents talking to other agents, agents talking to LLMs, public or private, agents talking to MCP servers and the responses. And it then becomes possible to instrument the chambers on the back end to actually say, can an agent reach a given server or service trying to do a certain thing? And so you can understand that in order to say who can drive the agent, which LLMs can it reach, what systems can the agent touch, you're actually going to need enforcement at three different locations. And so that would be our first architectural kind of understanding, if you will. And so that led us to introduce a new idea to us. We've had this idea of chambers for a while, and we realized we needed a new term, and we decided to call it enclave, something that could be bigger than a chamber and even have chambers inside it, but something that could start to have a single policy boundary for an entire project where you could put agents, LLMs, project tools, and project assets inside of a virtual, expandable, shrinkable, automatable container so that you could actually keep a certain project enclave separate from another project enclave. These enclaves could represent customer boundaries, like customer A's data is over here, customer B is over there. It could be different projects. It could be different development cycles. It could be different environments or data sets. You know your business better than I do. And so you can imagine that these enclaves, because they can stretch and expand to encompass the things, as you find projects and workflows that are using agentic technology, these boundaries can be shaped to fit around those particular assets. And so an example of that is right here, where maybe there's some group inside finance that's inside of a bank, and they're looking for fraud or something else. And so they've got certain AI instances running either on premise or in the cloud, and they have certain servers that may be inside these chambers with users and agents. And there's the idea of an AI session controller. That's that control that needs to be AI aware, where it can actually inspect things going from servers to LLMs, things going from agents to LLMs, things trying to go from agents to servers and backend data sets that are inside of chambers. Meanwhile, there could be an entirely different group of people, maybe some engineers that are actually using Claude code, or they're using it to automate the routing of circuit traces. There's any number of applications here that people would be using. And again, this enclave could have completely different tools and LLMs and MCP servers and assets inside it. And so this starts to show you a way that we can start to think about, how do we actually start to integrate the idea of I need something on the endpoint, I need something around the assets, and I need something with AI native intelligence in the middle. And this leads us to our second architectural observation. If you're going to control agentic behavior, you have to have an enforcement layer that's independent of the agent. This is important because, again, the agents have some reasoning ability. It's maybe not exactly human reasoning ability, but they have the ability to try different things. And what we learned in working with some of our semiconductor customers is that we needed to put the AI agents into a sandbox, and the only way out of the sandbox is through an endpoint control. And that endpoint control ensures that agentic traffic goes to the AI session controller, where the traffic can be inspected, logged, credentials can be managed, all of those kind of things. And then the traffic can actually pass on to either cloud models or to internal models, MCP servers, all of these kind of things. And that ensures that the agent in one project can't go over and talk to the agents in another project, so on and so forth. And so this encompasses the ability to cover off kind of discovery, reachability. Can we know that it's there? We sure can. Can we know what it can reach? Yes, because we actually have a control that's in line that can't be bypassed in order to know what's going on. We can check credentials, and we can actually inspect any of the prompts and the responses in a scalable way. More on all that to come, but what I'll point out at this point is just this architectural requirement that to do agents, you've got to have enforcement that's actually independent of the agent. Of course, the vendors make controls, but they're really not adequate to ensure that what you intend to have happen actually happens. And that leads us to a really interesting question. How much control is right? In other words, we've described that you need controls in three places, and we've said that these controls need to be independent of the agent. But how much control are we actually talking about? What I can assure you is that detection and monitoring is not going to be nearly enough. There have been a number of hacks that have been publicized recently where agents took like 17,000 actions in a space of less than 24 hours, working to do breaches on an automated basis. Detection and monitoring is not going to be enough when you have something that can execute 7,000 attack actions in less than 24 hours. So there are certainly generic controls that you can put up with VLANs and that you can put up with firewalls and things like that, but these are not particularly AI native. They're simply just reachability, kinds of things. All of the main AI vendors have some type of security attached to their things, but it's mostly about protecting their models. It's not as much about protecting your data, and it's making sure that their agents try to not hallucinate or, do really egregious things. those constraints probably aren't going to keep your intellectual property safe. Anthropic is not going to refuse to accept an upload of all of your customer data. That is not part of what they're promising you. And so we've talked about the basic idea of isolating agents and sandboxes, and that's part of it. But what we discovered is that you actually have to have some kind of behavior-based control where we're actually looking at the agent, what it's trying to do, and assessing that against a set of permissions or against a set of expectations. And we're going to call that declared intent enforcement for purposes of this webinar. Now, I am not going to read this slide to you. If you wanted to screenshot a slide, this would be one of the slides to screenshot in this deck, because a very important idea. It is not a new idea. This is an idea that we've understood for years in the context of zero trust for servers and for users. And that is simply that an AI agent's permitted actions should be declared up front. They shouldn't be inferred at runtime, and they should be enforced at a layer that the agent can't bypass. Well, what kinds of things? If you just look down the very leftmost column, you'll see some of those things that would be part of maybe declaring the intent of a thing. For an agent, it has a defined task. There's some data set or destination that it probably needs to get to, and it probably doesn't need to get to your healthcare information or your payroll. And so for that reason, we can define what might be reachable destinations. What tools is it allowed to use for LLMs and MCPs, or does it just get to go out to the internet and use all the LLMs that it can find? Probably not a good idea. Are there action classes that it's allowed to take or not take? Data classes that it's allowed to access or not? Can it delegate control or process to something else, or does it have to all happen inside the one agent? Do you have egress limits or token limits that need to be observed? Do you want to insist that it only uses certain models or certain providers? And these are all just examples of things that you could decide reflect your intent for this particular agent. And I think that you can see that compared to just firing an agent on a desktop, if you could control these kind of things, it would give you a lot of governance capability, compared to an monitored and an ungoverned system. So I'm going to give you a couple of examples of how this actually plays out in the real world. So I'm going to just show you some pictures of some things that happen to be from our product, but they'll be illustrative of the kinds of things that people need to see and that we've discussed so far. The first is something simple, like the ability to inventory all of the agents by system, to be able to say that I've got a certain host name, it's got an operating system, how many users are logged into that thing, what sandboxed agents are running on those, and be able to, have all of the statistics and things that you need to see, perhaps by the agent type, by the user, by the endpoint, and being able to sort and filter and export and, manipulate these kind of inventory things. Very useful if you're at the front end. I noticed in the survey data, there was some percentage of people that said they actually didn't know. They didn't know if they had agents or not. No judgment. Everyone starts there. Everyone finds out that they have agents that they didn't know were there because they're not hard to get. You can write one yourself, or you can have Claude Code write you one for almost free. So the fact that there are agents out there that people don't know about is just an action to take to say, hey, let's find out what's there. And that's where these journeys typically begin. We have had a lot of interest, particularly, again, because we've worked with some very high-end engineering organizations. And if you're trying to do very high-end, very difficult things, like route billions of transistors onto circuit board traces, then you can burn some tokens. You can use some inference engine. And so we've been asked to be able to monitor the kind of usage that's coming off of different environments, different agents. And so being able to categorize things by users, by providers, by enclave, by the agent and where they're headed. And again, be able to kind of sort and pivot and, filter around these things. And then to be able to enforce, to actually say, this workstation used, however many tokens today, and that's all they get for a day. And if it's above a certain threshold, maybe somebody ought to need to know about it. And so all of those kind of management things, of course, are in view by just this basic kind of session management that, again, you can't trust the agent to do it. It's just trying to do whatever it was told, and it doesn't really care about cost. But someone in your company does care about cost. And this is the kind of governance capability that lets you deal with that. we mentioned this idea of declared intent enforcement as our third architectural kind of priority, if you will. And here's an example of some of those kind of controls where you could filter on persons' names, email addresses. Do you allow phone numbers to be passed? Social security numbers. Is the agent allowed to deal in credit card numbers and IBAN or SWIFT codes and government IDs? Addresses, dates of birth, IP addresses. These are some basic categories. And our implementation allows you to specify your own custom lists, use regex expressions, all of those kind of things, because of course the intent for the agents that you have might be encompassed in some PII categories, but of course it could go well beyond PII to various data sources and classifications and servers and all of these different things. And so this, it provides a way to start to see, like, oh, yes, it would be possible to pick off of a list. It would be possible to put in some keywords that I know are relevant to this enclave and some different keywords that I know are relevant to a different enclave. These are not things that have to take weeks and weeks and weeks to do. These are things that can fall right out of project documentation, design flows, coding standards, and, other kinds of things that probably already exist inside your environment. If you need a way to instrument them and to make them real in the world, that's exactly what a capability like this is for. Another thing would be to stop the exfiltration of critical data. And this also will get to the idea of, can I log? Can I understand or document what has actually happened between agents and an LLM, or between a user and an LLM? Can I actually document that? And I not only want to have the proxy be able to say, hey, here's an IBAN or a banking number, and the system, basically comes back and says, sorry, no can do, that's blocked and that didn't go anywhere. But this ability to not only see this session detail also means that there could be a capability to store all of this information, to then offload it into data lakes and to other sources where you might have your SIM or other correlation engines running. For some of our customers, they need audit logs for regulated data. And so being able to have a source that can get this data, even if it's agents, even if it's going to an LLM, and to see both the put and the give back from the LLM or from an agent is actually very critical. And of course, if you have these declared intent kind of enforcement controls, then you can actually stop the exfiltration of critical data. And by having this inline capability of that AI session controller, this is what really keeps the information that is proprietary, the information that you're trying to make sure doesn't go to a public model. This is the capability that makes sure that that information doesn't actually get to those places, but stays where you have intended for it to go. So at the bottom line, what we're suggesting is that it's pretty important to find the agents that you have and then govern the agents that you choose to keep. This begins with discovering them. It continues with authorizing them by placing them into an enclave. And if you don't know what it is, it can be put into quarantine or studied. We can contain these agents inside of enclaves and sandbox policies that basically define where that agent can go. And with virtual chambers surrounding important assets, then you've got something at the source, you've got something at the destination, and with the AI session controller, you can actually observe exactly what the agents are trying to do as they go between the user and the back-end systems. And being able to see the prompts, the uploads, the responses, and the tool calls, that also then partners with an enforcement capability that can make intelligent decisions around those things. And of course, once this is in place, it gives you a governance capability that's actually maintainable. This is something that you can operate and then adjust over time. And the beautiful thing is, at no time does security have to tell the business unit what it can or can't do. In our experience so far, most security and IT organizations do not currently have the ability to tell the business that they're not allowed to use a particular agent or to use a particular thing. So what's necessary is a control that puts the governance and the governance handles and the governance controls that all of the IT and security people know need to be in place it gives a way to do them while still saying yes to the business and being able to instrument it in a way that allows you to have the conversations that need to be had for proper enterprise management and governance. So, as we wrap up the presentation part of this webinar, there's a couple of key takeaways. The first of them is that agents are coming. Whether you answered that you have a few of them or you answered that you have a lot of them, the reality is you're going to have more of them by the end of the year. One survey that was published recently said that 40% of enterprise software vendors will ship agents to customers by year end. So in other words, even if no one in your company is writing agents, but you use Salesforce, you use Workday, you use Microsoft, you're going to get some agents by year end without even asking. And your users will probably get some training and just turn them on because they're going to make some part of their life easier. And so in that world, there's kind of three things that we talked about that are big rocks that you're going to want to think about as takeaways from this webinar. The first is that you need an enforcement point that is independent of the agent. You're not going to be able to trust that each vendor ships you good controls or that public models have the controls that you need to work with whatever agents you have inside your environment. You're going to have some kind of enforcement point that you can put your controls into that are separate from the agent and that the agent can't bypass. We think that part of that needs to be declared intent enforcement. You're going to have some AI aware thing that is actually sensitive to what the AI is trying to do. Just having a simple packet filter is not going to work when you have something that can reason with human-like or human approximate reasoning patterns. And we observe that you're going to need that control in three places. And these controls ideally would work together between the endpoint, something that is in the infrastructure to do this like almost AI proxy thing, if you will, and the IT and OT controls, these chambers that sit on the back end. And we've introduced this concept of enclaves and chambers as being foundational for securing AI and agentic workflows. You want sandboxes on the endpoint, you want chambers around your OT, and you want enclaves to hold all of a project or an agent workflow, all of their assets into one place. So with that, I'm going to end the presentation portion of this. My contact information is here. If you want to reach out to me directly, obviously you can respond to the scheduling emails and they'll get back to us as well. And we'd be happy to have one of our application engineers talk with you about things that may be very specific to your environment. But I'm going to go ahead and stop this sharing and we'll take a look at some of the questions that may have come in.
Yeah, we have a handful of those. Thank you, Nathanael. That was terrific. There is one question about tokenomics, I believe, but you already covered that. So I don't know if you want to add anything to this. Does an agent get its own? No, that's a different one. Does an agent get its own identity or does it inherit the permissions of the user who launched it?
Oh, this is a good question. We've had this conversation a number of times with customers, and I think the state of the union today is that in most organizations, agents are running with user permissions. That's because an agent downloaded or a user downloaded it. The user is probably running the agent on their own server or desktop or inside their own little dev environment. And so that means that you probably have very over permissioned agents. You know, in the long run, do I think that's the way the industry will be? I do not. I think in the long run, we're going to have fully authenticated agents that have to present tokens or certificates or something that says, I'm this agent, and then we can know what that agent is permitted to do. The same as with a user. Because ultimately, again, I don't think that we want agents able to go into your payroll information or, change your benefit allocation just because they're running with your user permission, even though you wanted the thing to go do web research for you, So I think that there's a today state, and then I think that there's a state that the industry is going to move to as quickly as it can. And I think that's where companies that have a strong history of user-based access control are going to have an advantage, because if you already know how to do users, you're going to be able to accept some form of automated credentialing and then match that up to a permission list, right?
Good answer. This is the one I was talking about. I don't know if you want to add anything to this, Nathaniel. Can you actually cap what an agent spends? or only report on it after the fact? We worried about the agent running up a bill nobody authorized.
Ah, yes. The good news is we can stop it and then tell you about it. The order of operations is important here. Yes, it is good to be able to notify you about it, but if I tell you, oh, $100,000 has just left your building, you might want to look at it. That's very different than we stopped it at $25,000, but you might want to take a look over on aisle 7, rack 17. And so we actually enforce the limits that you set, and that enables you to then have the control at the point that it's needed and not just after something's escaped.
All right, more questions coming up. Which architectural pieces does your product provide? For example, your endpoint agent, microsegmentation, firewalling, of an enclave proxy, etc.
Yes, we actually provide a capability for each of the three areas. We do have an endpoint agent that we've used for years for user access. So it's a user aware agent. It is an agent that is already used to tunneling user traffic back to chambers. And so it has the right kind of hooks in it to be able to put an agent inside of a sandbox and then make sure that the traffic only goes encrypted to a proper place. Like the second part of the solution, we're calling it an AI session controller. That's our name for this capability of having a proxy, an AI aware proxy that is able to natively understand the conversation between an agent and an LLM. And then we've made the microsegmentation, if you will. I see that in your question. The microsegmentation backend of being able to put these chambers around, backend servers. So for us, the work has been to expand, on the one hand, our endpoint agent so that it can be AI aware, it can find the agents, it can inventory them, it can sandbox them. We've had to develop our AI proxy and session controller, and then we've had to add some additional instrumentation to our chambers so that it can be aware of the things that it needs to be told, based on what's happening with the agents and what's happening with the session controller. So we see ourselves as providers of all three.
Thank you, Nathaniel. I have a few more. If you are inspecting every agent to LLM interaction inline, what does that do to the performance? Our workflows are already latency sensitive.
Indeed. Indeed. I think this is a place where there's a good news. I think that if you were to measure the latency of asking a question of a public LLM or even one in your data center, the response time is usually measured in hundreds of milliseconds to actual seconds. The burden of going through our AI session controller is in low single-digit milliseconds. And because of the miracles of modern compute, that is very, very scalable. If you think about like the web proxies that you have running at the perimeter of your environment, some of you have very, very large amounts of web traffic that are successfully going through proxies every day. So, suffice it to say that all of this would have to be tested. I'm the guy that gets paid to tell you that it's good and it works well. But obviously you would test that, and we would expect to have to perform to, your latency and performance specs. It's not okay for the inline control to slow things down, right?
Thank you. There's a handful more coming up.
Yeah,
We probably have agents running we don't know about, quite common. What's the
indeed.
realistic first step and how disruptive it is to find out?
Okay, well, I'll tell you how we would find out for you. There would be two parts to the solution. The first would be a virtual machine that we would ask you to install somewhere in your environment. You could run it in the cloud, you could run it on premise, not important to us, but it's a single virtual machine, and you all know how to stand those up pretty easily. That would be the control plane, if you will, the user interface. The second thing we would give you is we would give you our endpoint agent for you to deploy onto some of your endpoints. Now, that agent, let's talk about it for a minute. That agent actually deploys passively. What I mean by that is it deploys its code onto a system, and it starts up, and all it does is contact the central brain. It doesn't make sandboxes. It doesn't make policy. It doesn't interrupt anything. All it does is visibility actions. And so this obviously means that you can observe it running. You know that it's not going to eat CPU or anything else. And that's what actually gives you the inventory data without doing any sandboxing, without doing any security configuration. If you just deploy the agent, literally within minutes, it's going to start coming back with all of the things. You leave that thing run for a couple days, and we're probably capturing 99% of all the agentic things inside your environment. You run it for a week or two, you're probably not getting anything new. So again, your environment may be slightly different, but that probably gives you some guidance. It's a two-part thing, and you know how to deploy agent software. You know how to test agent software. So of course we'd test it, make sure it's not going to blow anything up, and then you're going to use automated means to roll it out, and you'll start getting the reports back, within a couple of minutes.
Cool, thank you. There is one more. For a compliance audit, can you show exactly what an agent did in a given session, including what it tried and was blocked from doing?
Yes, we actually showed that in one of the screenshots. The AI session controller can actually log each of the sessions with the puts and takes, and it will definitely log anything that it blocks. And so we have some customers that are using this for auditing. Like there's environments where they have business partners and they need to be able to prove that certain things happened or did not happen. And having actual logs that can validate that is part of their contract. And so we are providing that capability today.
And there is last one so far. We run OT systems that can't take an agent. How do you control what an agent reaches on equipment that only has an Ethernet cable?
Yes, that is the entire world of SCADA systems, manufacturing automation, and building controls. Things that only have an Ethernet cable. What do I do? Well, I'm going to make the observation that the intersection of AI and OT is headed for you, even though nobody may have said so. And I say that for two reasons. The first is that most OT environments are very data rich. There's lots of sensors, there's lots of telemetry, there's lots of things happening. Humans don't do well with big data volumes. Agents do very well with big data volumes. So there's going to be a natural attraction of the processing and analysis capability to the data flows. The second thing that will happen is most OT systems are relatively simple. You could probably give the Rockwell API to Claude Code and have it write you a whole new user interface inside of 2 weeks. Now, you may or may not want to do that, but you might. Are there people out there that will use agents to try to find, small efficiencies that can reduce, defect rates by 2%? Of course there are. And if that's something that AI can do, that kind of analysis will very quickly find its way into OT world. And so I think you can appreciate, we didn't touch on it heavily in this webinar because we really wanted to keep the focus on AI, but I did briefly show you our Gatekeeper appliance that is designed to sit in front of critical OT infrastructure. And so you can imagine the power, like of these chambers that we have for IT devices, those same chambers are available for OT devices because of that hardware gatekeeper. And so it can actually sit transparently in line and create these chambers and control the AI access in and out of them the same as any server. And so if you're one of the people listening that actually runs assembly lines or has temperature sensors and ovens and CNC machines or whatever your version of all I have is an Ethernet cable, you should probably reach out to us and have the conversation, because I don't think you're probably being deluged by people that can talk intelligently about OT and AI in the same sentence.
I agree. Good. That was the last question that came in. So, Nathaniel, any final thoughts before we let everyone go?
No, just that I've enjoyed having the conversation with you, and thank you for the questions. I thought that there was a good variety of things there, and I think it shows the kind of interest that's actually out there in the industry right now. Everybody's got real problems. They're not theoretical. They're all things where everybody's trying to wrestle with something that's new. Those of us with gray hair or gray beards, we've been through more than one of these technology adoption cycles, and this is a big one. It may be bigger than cloud. It's certainly the same size as, and that means it's going to go on for a while. And so, we enjoy having this opportunity to dialogue with you. And if having a customized version of this conversation is interesting to you because we hit something that was interesting, definitely hit us up. And again, we'll have an application engineer get on the phone with you and, start to understand what you're doing. And we can share in more detail some of the things that we've done and answer some of the technical questions about scale and all those other things that, just can't happen on a webinar. So if that's you, raise your hand and let us know, and we'll look forward to talking with you soon.
Thank you for insightful session, Nathanael. And and thank you everyone for spending your time with us today. Have a great rest of your day.
See ya.
In your inbox. Bye.
Thanks so much.